24th shift to question paper chemistry. Let we have the look over this. See the question, which of the following 1 molar base, 1 molar acid leads to largest increase in temperature? Increase of temperature is more if strong acid reacts with a strong base, which releases more energy. So in that respect we can go further directly, that is HCl NaOH neutralization. But here two options we have. In that, let we check the millimoles which is more, that more millimoles will gives more energy. In case of 30 milliliters of 1 molar HCl with 30 milliliters of 1 molar NaOH, which is 30 millimoles each, and here the energy released is delta H minus 13.7 kilocalories per 1 mole. Here we have 30, so this is in terms of energy released in kilocalories. But if you see 50 ml of HCl, 1 molar 50 millimoles, another is 20 into 1 molar, which is 20 millimoles. But limiting reagent, here it is NaOH. So number of millimoles are less. That means relatively less energy is released here. The energy released is 13.7 into 20 by 1000 kilocalories, which is relatively less energy, leads to less rise in temperature. So in that respect, here we can see the more appropriate answer among the given is
30 ml of HCl with 30 milliliters of NaOH. Let me go for the next one. Here the elemental composition of the compound is 54.2% carbon, 9.2% hydrogen, 36.6% oxygen. If molar mass of compound is 132 grams per mole, molecular formula of the compound. So for this, let me first proceed for elements, what is their composition. Here 54.2% carbon with its atomic weight if we divide, and another one is 9.2% hydrogen, oxygen 36.6% oxygen. So here we get, this is 4.516 relative number of atoms and 2.287. These are relative number of atoms. Relative number of atoms when divided with the smallest value among them, this we get simplest ratio of atoms. Simplest ratio of atoms is approximately, this is simplest ratio of atoms. Here we can equate this nearly 2, this is nearly 4, and here is 1, that is C2H4O is the empirical formula of the compound. From this empirical formula, we can proceed for empirical formula weight. So this is 2 into 12, 4 into 1, and 16 into 1. Empirical formula weight is 44. To get molecular formula, N is molecular weight of the compound by empirical formula weight. It was given 132 is molecular weight of compound by 44. So here this is 3. That is, what is molecular formula with empirical formula given? Empirical formula N times. That is C2H4O, N times N value is 3. That C6H12O3. So C6H12O3 is,
this is the third option in this. Let we see the next one. Identify correct statements. OCH3, NHCOCH3 are activating group. In aromatic ring towards electrophilic aromatic substitution, element which is attached to the aromatic ring here, if it contain an atom that contain lone pair, now this acts as an activating group towards electrophilic aromatic substitutions, EAS. In electrophilic aromatic substitution, now the first statement OCH3, because it has lone pair of electrons over the oxygen, and same in NHCOCH3, nitrogen has a lone pair. Now this acts as an activating group. So statement A is correct. In statement B, CnOH or meta-directing was given. Deactivating groups, usually they are meta-directing group, but here OH is activating group because it has lone pair of electrons. So B statement is wrong. Cn and SO3H are meta directing groups. This statement, Cn has carbon with attached to more electronegative atom by means of multiple bonds. In that case, now carbon can behave as electron removing group. In that respect, now we can see C option is correct statement. Activating groups acts as ortho-para directing groups, that is correct activating groups. They increase electron density at both ortho and para positions. So these two positions are ortho, that means adjacent position to any group. Opposite position is para position, and remaining two positions are meta position. So here there is increase in electron density at ortho and para position, so which increases the possibility of electrophile towards that. That is, D option is also correct. Halides are activating groups. Halogens, fluorine, chlorine, bromine, iodine, these are deactivating by minus I affecting. Minus I effect is negative inductive effect because of their more electronegativity. So E is also wrong. So let we consider here the more appropriate in the given is second option is more appropriate. Let we see the next one. Based on the data given below, the strongest reducing agent is. Here we have reduction potentials. How to identify whether the given is reduction potential or oxidation potential. Here you can see E naught of Cr2 O72 minus Cr plus 3. Chromium from plus 6 state here reduced into plus 3. That means given is reduction potential. In case of chlorine also you can identify reduction potential was given. Manganese also same, MnO4 minus is turned into Mn plus 2. So reduction potentials given here. When reduction potentials are given, highest is standard reduction potential. Then it acts as good oxidizing agent. Whereas lowest is reduction potential, standard reduction potential, it acts as good reducing agent. What it indicate? It readily donate the electrons. That means the chromium is the best reducing agent among those based on given SRP values. Let me see the next. Given below are two statements. There is a graphical representation given for the half-life and initial concentration. So when the initial concentration was specified for the half-life, actually half-life period T half is related, half-life T half is proportional to 1 by initial concentration to the power n minus 1. As the initial concentration is here, it was specified with respect to the initial concentration, no change in half-life. That means this is first order reaction. For first order, half-life is equal to 0.693 by rate constant. That means independent on initial concentration. So statement 1 is valid for the first order is the correct relation. When we see the statement 2, log R by R naught versus time. Actually for the first order reaction we can identify rate constant is 2.303 by T log initial concentration by concentration at time T. So this reflect log of concentration at initial state by concentration at time T, which is equal to Kt by 2.303. Now from this one, when a graph is drawn between log of A naught initial by concentration at time t versus t. It is a straight line with the slope that is passing through the horizon. Slope is equal to k by 2.303. But the given graph was concentration at time t by initial concentration was given. So here it is very clear. This graph is, the graph here mentioned is not correct. The graph here is wrong. So in that respect, statement 1 is true, but statement 2 is false. So that is the second option in this given. Let me see the next one. The conditions and sequence that favors T2G3 EG1 configuration in a metal complex are. So what here it is mentioning, you can see T2G3 EG1. Here we have two sets of d orbitals. Actually, d orbitals are degenerated state, all the 5 d orbitals. They are of equal energy in absence of external field. But in case of octahedral complexes, the splitting of these d orbitals takes place into two energy levels. One is T2G and another is EG. Now, if the distribution of electrons takes place, here what was given as per the given is this T2G3 and EG1. This distribution is possible if this splitting energy, what we called splitting energy for the octahedral delta O, if it is less. Less splitting energy is usually favored in case of weak ligand field. So weak field ligands causes less splitting because delta O depends on strength of the ligand and metal ion oxidation state of the metal ion. So one of the conditions what they had given is less splitting energy it reflect because Eg receive the electron. Now weak field ligand condition. One more is what about the spin? The spin is calculated based on the number of unpaired electrons. So here the unpaired electrons are more, no pairing. The spin only magnetic moment is root over n into n plus 2 Bohr magneton. So here it is high spin because 4 unpaired electrons are present as per the given. So it should be weak field ligand with high spin complex condition. So this is validated here as per the given one. The fourth option is indicating in this. Let me see here another one condition is given. Compound A from the following reaction sequence. A is aquaresia and this by the reaction with KNO2 in ammonia solution, further by acidification, yellow precipitate. Actually, here what was given condition is this aquaresia is commonly used for the 44th group in general separation, that is in qualitative analysis. We have in fourth group Mn plus 2, Zn plus 2, Ni plus 2 and CO plus 2. Here cobalt will gives the yellow precipitate as per the given condition. Actually CO plus 2, that is in form of COS with aquaresia. Aquaresia is concentrated nitric acid and concentrated HCl, which is 3:1, 1:3 ratio of concentrated nitric acid and concentrated HCl. With aquaresia, here we are getting COCl2. The CO plus 2 by addition of NO2. Here with NO2 minus by acidification, CO plus 2 is changed into CO plus 3 along with NO. Now cobalt in plus 3 state with NO2 minus, that is KNO2. Here it proceed for formation of K3CONO2 6 times. This is actually yellow colored precipitate what we get. So we can identify here the condition is satisfied as per the given for the COS, cobalt. So correct one for this given question is the 3. Let me proceed for the next one. The structure of major product form in the following reaction is. Once the reaction, if you noticed, the reaction has iodine and bromine on aromatic ring, whereas chlorine is present on alkyl part. Aryl halides have very less reactivity towards nucleophile. That means nucleophilic aromatic substitutions are takes place only in specific conditions. Alkyl part, alkyl halides can exhibit nucleophilic substitution relatively more easily. So in that regard, here it is very clear. The reaction here is happened for alkyl part of the given molecule. We can see here AgCN. Now, what is the atom in this which acts as a nucleophile? Silver and carbon, more covalent property is present. The only nitrogen lone pair can proceed as a nucleophile now. So from this given reagent which is reacted with this alkyl parties, nitrogen has to participate in that nucleophilic substitution. When nitrogen is involved here, the alkyl group is now receiving further with the loss of AgCl precipitate. This is the product obtained. So what is the correct one? Here is the 3 is the more appropriate among the given. Now let me see the next one. The successive 5 ionization energies of an element are 800, 2427, 3658, 25024, 32824. In this you can identify a larger jump in ionization energy happened in between third and fourth ionization energies. When a larger jump is happened, that indicate removal of 3 electrons is easier, but 4th electron removal requires very large amount of energy. That means 3 electrons are present relatively with less attraction. So this is possible when the configuration is ns2 np1. That means 13th group elements have such type of ns2 np1 configuration. So this is the 4th one is more appropriate answer for this given. Let me see the next one. Here what was given is RCN was specified. This RCN with SnCl2 and HCl. Cyanides by reduction with stannous chloride and HCl. First they are converted into imines. Imines further undergoes hydrolysis into aldehydes. This conversion of cyanides into aldehydes through imine intermediate is Stephens reduction. So A is related to the Stephens reduction. Next, acid chlorides by reduction with Lindlar's catalyst, PDBaSO4 and hydrogen. This is Lindlar's catalyst. Here acid chlorides are reduced into aldehydes. This reduction is Rosenmund's reduction, acid chlorides directly into aldehydes. Here ketones are not possible by Rosenmund's reduction. Next, aryl alkanes by reaction with CrO2 Cl2 in CS2 and further hydrolysis. Chromyl chloride reacts with the CH3, that is toluene, alkyl part of the aromatic ring, that further undergoes hydrolysis to give the aldehyde, which is called Ettard's reaction. Next, benzene ring by the reaction with CO and HCl. This reaction is actually over the aromatic ring introducing aldehyde group. CO, HCl in presence of AlCl3. Here we have the electrophile. This electrophilic property because of AlCl4 minus. The electrophile is not very strong electrophile, and the ring which is deactivated doesn't exhibit the reaction here. So aromatic ring should be activated aromatic ring and it should not be deactivated, then only this reaction takes place, which is Gutterman-Koch reaction. So Gutterman-Koch reaction is for aromatic rings, those are activated and not deactivated. If there is no activation of the aromatic ring, presence of Lewis bases, Lewis acids like AlCl3 is necessary, then only the reaction is carried out. Say here, A is matching with 4, B with 3, C with 1 and D with 2. This is there in option 1. This is the more appropriate among those given. Let me see the next one. For the given reaction, aniline is converted into orthobromoaniline. Actually, here very important information regarding the aniline reaction is when aniline has the reaction with bromine directly with H2O or even in CCl4, there is a white colored precipitate is formed, tribromo compound. So here what he had made is bromination at ortho. Even the priority by having any substituent at ortho, the priority of the substitution will shift it towards the para. So we should carefully identify how the reaction can be carried out to shift that electrophile Br plus towards only ortho. See, when aniline is treated with sulfuric acid, first acid base reaction takes place here. Anilinium hydrogen sulfate is obtained. This anilinium hydrogen sulfate, by heating to a temperature of nearly 473 Kelvin, SO3H group is shifted towards para position. Then by the reaction of acid anhydride allow this reaction to happen at NH. This is the nucleophilic property for nitrogen. Thereafter, the bromination if carried out. Now the position para was already occupied. So only possibility is ortho substitution of the bromine. And this by treatment with NaOH. Now the reaction can be reversed by heating. SO3H group also released. Heating is first preferred because by heating SO3H group is easily detached and NHCOC acyl group is only present, acyl COCH3. Here SO3H is replaced by the bromine, then NaOH will carry out this reaction to take place. This is the reaction. Actually here we have acyl group. This is as anhydride. In this, here is the electrophilic property. So, only this electrophile is added with the nitrogen of aniline part. This is nucleophile. That is how the reaction takes place here. The reaction will carry out. COCH3 is added. Let me see the next. See, sulfur by the reaction with oxygen forming SO3 plus 2x was given. We should have more careful about this one. Here, what happens is sulfur with gaseous oxygen form SO3 gas, delta H is minus 2x because it is an exothermic reaction. And further SO2 with oxygen form SO3. Here delta H2, let we call it, is minus y kilocalories. So heat of formation of SO2 is nothing but sulfur by the reaction with oxygen to form SO3. Here this is delta H1 minus 2x. If we reverse the second equation, by reversing the second equation, according to Lavoisier-Laplace law, which is also called first law of thermochemistry, the sign of delta H is reversed. Now, by simply adding these two, sulfur with O2 form SO2. So, what is resultant delta H is y minus 2x. So, y minus 2x is at the fourth option. We can identify here this is the more appropriate answer for that given. Let me proceed for this. Next, when ethane 1,2-diamine is added progressively to an aqueous solution of nickel 2 chloride, the sequence of color change observed will be. So, nickel 2 chloride, if we take, this by the reaction with ethylene diamine, En. Here En replaces two water molecules because En is a bidentate ligand. Then NiH2O4 ethylene diamine again reacts with one more molecule. Finally, we are getting En thrice ethylene diamine. This is actually obtained. This first one is actually green colored compound which has further pale blue changed into blue colored and further it changed to violet color. We can identify that change here. What happened is nickel here which has +2 state. The nickel which is with the 3D8 configuration in +2 state. The splitting of this we can identify in octahedral geometry. The splitting energy for these 8 electrons, those are distributed here. The delta O is gradually changes by change in the ligand. The ligand strength is increasing here. Ethylene diamine is a strong ligand. When the strength of ligand increases, the delta O, that is splitting energy, is gradually increased here. Now the color change is happened towards, here you can see green towards the violet gradually because of that change in splitting energy. So what is the more appropriate here is green to pale blue, then to blue, and then it is to the violet. This is the more appropriate among the given answers. Now let we see here the next one. For the reaction I2 plus H2 gas gives 2HI, the attainment of equilibrium is predicted correctly by when the reaction is in progress. Concentration of reactants decreases and that of the products increases. But at equilibrium, the concentrations of reactants and products they remains constant. H2 and I2 both are reactants, both the concentrations from the given position has to be decreased and HI has to be increased. So this is validated in the given, among the given, this is validated only in case of first option. Let me see the next one. For hydrogen atom, the orbitals with the lowest energy is R. 4s, 3px, 3dx square minus y square, 3dz square, 4pz. Choose the correct answer from the options given below. Actually, in one electron species, that means in single electron species, in one electron species, all the orbitals in a given orbit, those are having equal energy. These are in an energy level. So here these have equal energy. Now in that respect, we can identify the energy of 2s and 2p are equal, energy of 3s, 3p, 3d are equal, 4s, 4p, 4d and 4f are equal in the energy. Now energies are gradually, here you can identify the energies are gradually increases with the orbit number, that is for uni-electronic species. We have to validate here the Bohr's model for the uni-electronic species. So in that lowest energy means 3p, here you can identify lowest energy among those is 3p, 3d and also here also 3d. These have relatively lowest energy in that. So more accurate answer for that one is fourth option is more accurate in that. Now let we proceed for the next one. In the given structure, number of sp, sp2 hybridized carbon atoms present respectively are. We can identify in this, the first one is carbon with only, if all the bonds for the carbon are carbon with only sigma bond, it is sp3. Carbon with one pi bond, if we have, it is sp2. Carbon with 2 pi bonds, sp. So here you can identify in that the given, here there is for the given structure, we can identify cyanide carbon sp and next carbons are with 1 pi bond sp2. Here we have sp carbon and in the middle this is sp3 carbon, again sp2, sp2 and here is sp2 carbon, this is sp3 carbon. So in that respect you can identify the number of sp carbons are, sp carbon atoms are 3, whereas sp2 carbon atoms here are 5. So what is more accurate answer for the given is third option in this. Let we see the next one. Here we have list of the compounds. This was given as adenine. Adenine is a purine. Remaining cytosine, thymine and uracil, they are pyrimidines. So purine, which is two cyclic rings are present. One molecule is only having the two cyclic rings. This is, you can see, third molecule is only having that. Now another is cytosine. Cytosine structure is differed from the thymine and uracil. NH2 group is present for the cytosine. So this is 4 in that. Now you can see thymine and uracil. Thymine is present in DNA and uracil is present in RNA. Thymine has slightly more molecular weight compared to that of uracil. Molecular weight of thymine is 14 more than uracil. So here you can identify 2 is thymine and uracil is 1. So this is validated. You can identify that is matching to the here A3, B4, C2 and D1 is related in that second option. More correct is the second. Next, let we see here Ti3 plus titanium. Titanium is originally, when we see the configuration of that, 3D2 and 4s2. So when it is Ti plus 3, then you can write it is 3D1. So 3D1 means in d orbitals, d subshell, if we consider only one unpaired electron is present. Number of unpaired electrons gives us a spin only magnetic moment, which is root over n into n plus 2 Bohr magneton. Here this is 1 into 3, root 3 value 1.73 Bohr magneton, that is for the Ti plus 3. Next, if you see vanadium, vanadium here we have Ar 3D3 4s2. So V plus 2 is Ar 3D3. With that you can identify we have 3 unpaired electron for that. 3 unpaired electron, spin only magnetic moment, root over 3 into 5. So here we have root 15, which is 3.87 Bohr magneton. Next, another one is nickel Ni Ar 3D8 4s2. For the Ni plus 2 Ar 3D8 4s0. 3D8 configuration, if we see the distribution of electrons here, you can see so 2 unpaired electrons are present. Spin only magnetic moment is 2 into 2 plus 2. So root 8 Bohr magneton, that is 2.84 in Bohr magneton. Scandium is Ar 3D1 4s2. So Sc plus 3 if we take Ar 3D0 4s0. So here no unpaired electron, that means spin magnetic moment here is 0. That means you can identify for Ti plus 3 we have one unpaired electron, 1.73 is related to that. And vanadium is related to this 3.87. Nickel is and scandium is 2. So 3142. This is observed in case of fourth option, we can see. Now let we proceed for the next 69th here. The first ionization energy of lead is greater than that of the tin. The first ionization energy of germanium is greater than that of the silicon. When we see the 14th group elements, in 14th group elements, first ionization enthalpy, if we see that ionization energy, carbon is more than silicon, next germanium, next lead and tin. And second ionization energy is also, here we can identify the same order for second ionization enthalpy also. Lead has poor shielding effect of inner 4f orbitals. Lead comes after lanthanides, so lanthanide contraction consequences observed in case of the lead. The nuclear charge is more over the valence shell here, which is reflected in ionization enthalpy of the lead. Not only that, here you can identify in IE3 the order of ionization enthalpies is again a slight variation you can identify in this case also. And fourth ionization enthalpy, carbon, germanium, silicon, and again lead and tin. Very important feature here we can identify lead, even though it is a 14th group element, lead Pb plus 2 is more stable than Pb plus 4. So when we see second and third ionization energies, relatively more difference in second and third ionization energy is observed in case of lead, which reflect the more stability of plus 2 state. Because of that, Pb plus 4 state, it acts as very good oxidizing agent because it is unstable in plus 4 state due to the lanthanide contraction consequences, the poor shielding effect of inner 4f electrons. So as per this, what we observed here, you can identify statement 1, the first ionization energy, the first ionization energy of lead is greater than that of the tin is correct, but first ionization energy of germanium is greater than silicon is not correct statement. So what is the more appropriate answer here is fourth answer. Let me see the next one. Here what was the statement mentioned is experimentally determined oxygen-oxygen bond length in O3 are found to be same and bond length is greater than that of OO but less than that of the single OO bond length. When we observed ozone, in case of ozone, here there is a resonance structure is observed for the ozone. Because of that, both the bond lengths are the resonance hybrid, if we mentioned, both have single bond and double bond character here, and the bond length is intermediate between single and double bond length. So the statement 1 what they had mentioned is correct. The strong lone pair repulsion oxygen atoms is slowly responsible for the fact that bond length in ozone is smaller than that of the double bond but more than that of single bond. It is not smaller than double bond, it is more than double bond length but less than that of the single bond. So statement 2 is a false statement. So in that respect, you can say statement 1 is true, statement 2 is false statement. So more correct answer is 1 is the more correct. Let me see the next one. Here we have an integer question. Consider a complex reaction taking place in 3 steps with rate constants K1, K2, K3 per mole inverse respectively. The overall rate constant K is given by the expression. Actually, Arrhenius equation K is equal to A into e to the power minus EA by RT. When we see this Arrhenius equation, this let we apply for the given one. A into e to the power minus EA by RT is equal to K1, that is A1 into e to the power minus EA1 by RT into K3 was given. So A3 into e to the power minus EA3 by RT by A2 into e to the power minus EA2 by RT to the power whole, this is 1 by 2. So if we simplify this one, EA by RT is equal to 1 by 2 into EA1 plus EA3 minus EA2 by RT. So this is EA is equal to EA1 plus EA3 minus EA2 by 2. Now here let we substitute the values given. What is the value given? Activation energies are respectively. So 60 plus 10 minus 30 by 2. So this value is 40 by 2, which is equal to 20. So we can identify the overall energy of activation in kilojoules per mole. So as per the given energy values are also activation energies kilojoules per mole, no change in the unit, same you can represent. It is 20 is the correct answer for this one in kilojoules per mole. Let me see the next one. In Carey's method of estimation of halogen, 0.25 grams of organic compound gave 0.15 grams of silver bromide. The percentage of bromine in the compound is. So actually here we have percentage of halogen in Carey's method is atomic weight of halogen by molecular weight of silver halide weight of silver halide by weight of organic compound given into 100. Now for the bromine, percentage of bromine, bromine atomic weight is 80 by 180 into the weight of silver bromide by the weight of organic compound given into 100. So this is 80 by 180 into weight of the silver bromide was given 0.15 by 0.25 into 100. So this is nearly 25.53. But what he had given is we have to represent that in terms of into 10 to the power minus 1 percentage. So here you can identify this is 255.3 into 10 to the power minus 1 percentage. Nearest integer we have to round off, that is 255 is the nearest integer. Let we see the next one. The absorbed and normal molar mass of compound mx2 are 65.6 and 164 respectively. The percentage degree of ionization of mx2 is. So we can identify here I, that is 1.5 factor, is equal to normal molar mass by absorbed molar mass in the solution. This is the 1/2 factor. So what it was given is 164 by 65.6, that was given. This value is 2.507 I value. Degree of dissociation alpha is equal to I minus 1 by n minus 1. The given is mx2, which dissociated as like this. What is the n value here is 3 ions are obtained from one molecule. So here alpha is 2.507 minus 1 by 3 minus 1. So 1.507 by 2, which is 0.75 by neglecting the next one. So 0.75 is indicating the percentage they are asking, which is the percentage of the ionization is 75% of the ionization, which is the nearest integer. Let me see this next one. The possible number of stereoisomers of 5-phenyl pent 4-2-ol. Here this is chiral carbon, and here we have a stereogenic center here also. Now you can identify at this double bond condition, you can write E or Z. Now E has possibility of DL and Z also with a DL. So total number of stereoisomers possible for this one given compound is 4 stereoisomers are possible. Let me see the next one here. Hydration with molar mass hydrocarbon with molar mass 80 gram per mole and 90% carbon has. So now you can identify the hydrocarbon which has already 90% of the carbon, which was given molar mass is 80 grams. That means in 1 mole what is mass of carbon is 80 into 90 by 100. So this is 72 grams is carbon and remaining mass is hydrogen. So what is that? 8 grams is the hydrogen. Now what is number of atoms of carbon? Number of atoms of carbon 72 by 12, that indicates 6 carbons are there. Number of atoms of hydrogen, which is 8 by 1. So what is this is molecular formula of this is C6H8 is the molecular formula. Now double bond equivalent or degree of unsaturation, double bond equivalent or degree of unsaturation for hydrocarbon exclusively if we have hydrocarbon which is represented as CXHY consider. Now for this one you can write it as x plus 1 minus y by 2 is the degree of unsaturation. So what is the degree of unsaturation for this one is 6 plus 1 minus 8 by 2. So 3 is the degree of unsaturation for this given compound. Answer here is